Welcome, everyone. So this will be like a continuation of this morning's talk when I said that, large-scale bridging is dead. And now I'll tell you why. And you know more or less who I am from the morning session, so I'm the grumpy old man that always complains how something doesn't work correctly. And recently I got into the virtualization problems, particularly how it impacts the networking side. And interestingly, everyone is ignoring that. So you have the OpenStack, right? It has open compute and open storage, and there is nothing on the networking side. They're just ignoring that, hoping that we will sort out their problems for them. So the cloud problems usually start on a golf course, where your CEO is talking with the competitor CEO, and they are claiming how they are launching the cloud services. So your CEO comes back to your company, and he talks to the technical director, and he says, we need to launch the cloud service. And so the technical director comes and talks to you. We're launching cloud services. Are we? Yes, next week. Okay, what type of cloud services? I don't care. Has to be cloudy. So let's get into what this cloud services could be, potentially. And I just wanted to draw a typical structure of a web application. So from the source code down to the scripting environment, web server, database server, file system, and down here the low-level block storage and CPU and RAM. This is how every typical web application on the market looks like today. And these are all the possible cloud services that you could offer. Actually, you could offer a cloudy solution on every one of these interface points. From software as a service to platform as a service, which is like what Google is doing with App Engine, or database as a service, which is what Amazon is doing with their, whatever they call it. It's MySQL in a cloud. Or storage as a service, yet again, what Amazon is doing with S3. Or block storage as a service, which is what Amazon is doing with Elastic Block Storage. And for us, for the networking people, all these things are just the applications. We don't care. Most of them run on TCP, so we don't care. This is like voice. We don't care about voice. It's an application just above us. It needs its quality of service, fine with that, but not more. What's really problematic for us is the infrastructure as a service. And I'll show you in a minute why that's the problem. So what's the difference between a typical web hosting that everyone is offering today and the cloud service? The cloud service should be scalable, elastic, and on demand. This is what's different between someone offering web hosting and Amazon. With Amazon, you can click, start 5 instances of your virtual machine, and you can deploy their elastic load balancing to load balance the load to those instances. And you can even say, you know what, if the load increases, start additional instances. You can't do that in a typical web hosting environment. It's too static. Okay? The real trick is that you need to have orchestration. And this is the good part of what Amazon is doing. Everything else they do is boring. But they do have excellent orchestration. So from the GUI, you can solve every problem on this picture. And it's deployed in seconds. That's what's so cool about their services. Plus, they have an API, so you can write your own scripts that deploy things like instances without your intervention. And it has to scale. You might not need to scale to the Amazon size. Well, I hope you might. That would be great. But you need to have a scalable network. As I said, most of these cloud offerings are for us. networkers, just a TCP application. So we don't really care. What we do need is a scalable and robust and resilient layer 3 network. So if the network is not stable, then of course we have a problem. And there is a lot of inter-server traffic. So in traditional web hosting, everything was on one host. So you had your Apache server that had multiple virtual servers on it, and they were using a local instance of MySQL, writing maybe to a local disk that was occasionally backed up. Okay? That's a low-cost web hosting. What we have here is we have a VM instance talking to another VM instance, which can be anywhere else in the network, talking to a disk, which is somewhere else in the network, talking to who knows what else. So you get a lot of traffic inside the data center that you didn't have before. And it's very important that you solve the load balancing problem. So whatever cloud service you deploy, it has to scale. And there's only one way things can scale in the TCP world, and that's load balancing. And you must have a load balancer that has APIs. So if your load balancer requires you to log in and type configuration commands to configure a new service, that will not work. It has to have an API where you can provision new virtual IP addresses and tie them to physical IP addresses through an API. Otherwise, you can't do the orchestration stuff. Now, let's focus on what I said was the hard part, which is the infrastructure as a service. And usually, this would be called server virtualization. So in the enterprise environment, we call this server virtualization. In the service provider, well, in the cloudy world, this is infrastructure as a service. Same technology, same problems. The only difference is the scale and the orchestration. And the question that you should ask yourself as a networking engineer is, okay, now I have these logical servers running inside a physical server. And they obviously need access to the network and to the storage. How do I solve that? The way it usually works is, on the storage side, you have files on a file system that appear as logical disks to these virtual machines. And there is a SCSI emulator somewhere here that transforms read and write requests to the disk into read and write requests to the file. And this is, for example, what OpenStack provides you with its storage component, or what VMware provides you with the virtual disks or Hyper-V or any other virtualization platform. The interesting part is the red path, where all these virtual machines have to access the network through a single connection. And the only reasonable way to implement it is to have a switch, a layer 2 or layer 3 switch inside the hypervisor. There's no other way to make this work reliably, unfortunately. I mean, I hate switches being in boxes that are not under my control as a networking engineer, but there's nothing we can do about it. And the real problem in cloud world is, how do we solve the multi-tenancy issues? So we have, let's say, Coke and Pepsi are both our customers. They both run virtual machines on our infrastructure. And of course, we want to use the infrastructure as efficiently as possible. So we will put Coke's and Pepsi's virtual machines on the same physical server. Okay? Somehow, it's not a good idea if they can see each other. So we need to solve that. And there are a few approaches. Like early Amazon approach was, well, this is what you get, and either you're happy with it or you can go away. And what Amazon gave you initially were just random private IP addresses and packet filters in front of your virtual interface. So they would give you some random private IP address, tell you to get used to it, or go elsewhere. And then they would implement packet filters that would protect your virtual machine from anyone else in the same subnet. This is very easy to do for Amazon because they're running Zen server. And Zen server is actually based on Linux kernel. And Linux kernel has a built-in firewall called IP tables or EB tables for bridging. What Amazon can do is they just download the IP tables into the Zen hypervisor, and they've solved the firewalling problem. It doesn't work as well in VMware because they have a totally proprietary kernel. There are a number of add-on solutions for VMware that do something like that, like vShield, Zones, or App from VMware. Or I know there is a solution from Juniper. And there's one from HP. And there's one from McAfee, probably. And all these solutions have a serious problem. They only influence packets that are on the same physical host. So you want to implement security in VMware world, you have to deploy a firewall on every physical host. Obviously, that doesn't scale. So what does scale is something that Cisco rolled out half a year or so ago, and it's called Virtual Security Gateway. And it's exactly the same architecture as OpenFlow, if you remember from this morning's session. It's not using OpenFlow, it's totally proprietary, but it's exactly the same idea. A packet from a virtual machine goes through the firewall and out, and back through the firewall and in, until the firewall decides that now this is a trusted session, it's okay, it can pass through. And then the firewall downloads the 6-tuple, so source destination IP address, protocol, source destination port number, plus VLAN, into the switch in the kernel. And from that moment on, it's switched at wire speed. So exactly the same thing as OpenFlow. OpenFlow would download flow entries into switches, and VSG would download flow entries into VEM, which stands for Virtual Ethernet Module. And this is like the only scalable solution for security in VMware world at the moment. And you can use it in two ways, now coming back to the cloud services. Option number one is you just have a centralized pool of devices that serve all customers, and you use some sort of fancy GUI to configure it. Or you say, OK, dear Mr. Customer, you're so smart, you can do it on your own. You want to do it on your own? Fine, do it. And deploy a VSG per customer. VSG is just a VM. So it's a virtual machine that can run anywhere. It just needs connectivity to the switching module. And it's a regular Nexus OS instance running as a virtual machine. So you connect to it with Telnet. You configure it using the standard configuration commands. And you have your own firewall in the cloud doing whatever you want it to do. Not bad, right? Now, the next problem we're facing as the networkers are the application people. Now, they're not a problem, they're a challenge. So usually you get requirements like this. Okay, I have this external firewall and load balancer, and then I need an outside segment where my web servers are sitting, and these web servers are talking through an intermediate segment to the application servers, and the application servers are talking through a more secure segment to the database servers. Right? This is how the application people think application design should look like. Logically, they're right. This is not the best way to implement it in networking, but you know, they don't get it. And eventually, you ask them, OK, how will you do software upgrades? So how will the database server reach an outside web server so it can download the patch? Will it go through all these layers? So will you turn all these things into web proxies so that it can go through? And that's where the application people get the oops moment. Like, what do I do? So we need to re-engineer the solution afterwards to make it work. But anyway, the point is that you need virtual segments. And there are like 6 different options how to do it. And I'll walk you through all 6 of them. The first one is a totally user space solution. So there's a company called vSider, and there are probably a few others doing something similar. And what they're doing is they have an Ethernet driver for Linux that encapsulates MAC frames into IP and encrypts that. So any virtual machine can talk to any other virtual machine anywhere in the world, and they appear to be on the same IP subnet. One virtual machine could be in your data center, the other one could be at Amazon, the third one could be at TerraMark, the fourth one could be at DrexSpace. And they would all look like they are in the same subnet. And I really grilled them about the details, and it seems they know what they're doing. So they had the answer for almost every challenge I posed to them, which is cool. They do encryption, so you're safe on this side. And they even handle IP address changes. So if your Amazon VM gets a different outside IP address, they can handle that, for example. And they even handle the cloning. So if you clone one virtual machine into another one, they figure out that they have a duplicate now. So one of them can't register into the subnet, and you have to change that. The drawbacks, it's Linux only, and it requires user length changes. So you need to install a third-party device driver into your Linux, which is not something that most people would like to do. So there's another option called Cloud Switch. Yes?
It's mentioned as Linux only,
yeah.
But does it work, or there's any port for systems like a FreeBSD, for example?
I don't think so.
Because in theory, you can use some packages from Linux on a FreeBSD.
It's a device driver, so it's pretty tightly.
Close to kernel.
Yeah. Chris Marino sent him an email.
Okay.
Yeah. He's also on Twitter. He will be delighted to answer.
That's good.
Cloud Switch is the next solution, and their primary use case is what some people love to call cloud bursting. So the idea is very simple, and it's way overhyped, but it makes sense in some environments. So you run some CPU-intensive tasks in your data center, and you run out of CPU power, or out of RAM, or out of storage, or out of something. And you want to offload, instead of buying more, you want to offload that into the cloud. The problem is that these machines running in the cloud have to access the data back home, or they have to report the results back home. Or you have the virtual machine that's up and running, and you don't want to port that into some weird format so that Amazon could use it. And Cloud Switch addresses exactly that. So the idea is you have running virtual machines in the VMware environment, and then you stop a virtual machine, you go to vCenter, you click, and you say, move this to Amazon. And the virtual machine is moved into Amazon's EC2 cloud. And the virtual disk is moved, and the connectivity stays the same. It's still in the same VLAN. Cool? I mean, it looks too good to be true, but it actually works. Of course, the problem is that there is some latency in here, so things might not work as fast, especially if you have like 50 or 100 milliseconds from here to Ireland. But, well, if you take that in account, it does work. The way they do it is pretty convoluted, but that's the minimum amount of complexity you need to make this work. In Amazon, they don't start your virtual machine, they start their virtual machine. And their virtual machine has a nested hypervisor. So it's something like Zen inside Zen. And that nested hypervisor provides the support for a VMware virtual machine. So they have implemented VMX-Net3 device drivers so that VMware device drivers work with this, and it translates the requests into IP packets, encrypted, and sent to so-called cloud switch instance, which is the cloud part of the bridging solution that interacts with these hypervisors and sends the packet back home. Back home, you have a virtual machine running inside your VMware. It has 5 interfaces, and you can link 4 of them to 4 VLANs. So you can link 4 VLANs with 1 virtual machine into the cloud. And they're pretty smart. They still do flooding and broadcasting, so I'm not happy with that. But at least because they know what they're doing, they know what these MAC addresses are, so they're not flooding the unknowns. They're not flooding packets with unknown destination MAC addresses because they know that they cannot be here in the cloud. Okay? The beauty of this is it works transparently with VMware, and you don't need any changes on the virtual machine side. It just click, move, go, be there. What we usually have to do in the data centers is what I call the ultimate scalability failure, which is VLANs. So the only thing that people like VMware give us is a layer 2 VLAN aware switch in the hypervisor. And they say, we gave you VLANs, we solved the multi-tenancy issues, now go figure it out on the network side. Oh, thank you. Ever heard about VLAN limitations? Best case, if you have the best equipment in the world, you can support 4,000 VLANs. If you need like 4 segments per customer, that's like 1,000 customers. Not much, right? So we have a real problem. And some people want to move the virtual machines from one physical server to another. You want to do that? You need the VLAN between those 2 physical servers. And some people have the crazy idea that any virtual machine can move to any physical server anywhere in your data center, which means that you have to have bridging all across the data center. Yeah, that scales. And that's reliable. Okay? So we need something better. And some people came up with some really creative ideas. They said, well, we don't want to use the data center switches from our beloved vendor. That same vendor has carrier Ethernet switches. Would you imagine the large-scale bridging problem was actually solved in carrier Ethernet because we have large-scale networks that do work. So why don't we use that same solution in our data center? There are ideas about deploying provider backbone bridging or VPLS in the data center and use VLAN translation or whatever the favorite term is for your favorite vendor and translate VLANs into something more scalable here and solve the bridging problem that way. In theory, it works. In practice, it's too complex. Because it works in carrier Ethernet world because they have days to make changes. Okay? You want to have a new connection to your home. It takes them weeks or months to pull the fiber. And then it takes them days to connect it and a few more weeks to turn the service on. We don't have that time in the cloud business. In the cloud business, this has to be done in seconds. And there's simply no orchestration software on the market that would allow you to do this in seconds. So although this is, from the technology perspective, it's sound, it might even work, it's too complex from the operational perspective. So it's a no-starter. There are a few vendors pushing something called edge virtual bridging, or 8.1 QBG. They love writing white papers, how well everything will perform after this is implemented. And there are like 3 or 4 major vendors that signed that white paper. So it was a joint interoperability effort in writing a white paper. We haven't seen any products yet. And that white paper is like a year or more old. And the standard is still not completed, by the way. So the idea is good. The idea is very good, actually. Because this standard defines something called VSI, which is the standard terminology for VNIC. VSI Discovery Protocol. So the hypervisor could tell the network what it needs. The hypervisor could tell the adjacent switch, hey, Mr. Switch, I have a new virtual machine, it belongs to this VLAN, or it belongs to this group ID, and group ID is 24-bit long, so plenty of space. Could you please provision the network to support my needs? Sounds great, right? If you want to stick with VLANs, this is like a perfect solution. It only has one problem. It works well in PowerPoint only. There is no software on the hypervisor side that would support it. vSwitch from VMware doesn't support it. Nexus 1000V from Cisco doesn't support it, obviously, because Cisco is the only vendor not on that white paper. Because Cisco has a different solution. QBH is your solution, and VMFAX is actually a combination of QBH plus VDP from QBG. And so VMware is not interested, Cisco is not interested, Open vSwitch is not interested. No one on the hypervisor side is interested because they think it's not their problem. They think the networking guys should solve their networking problems for them. So it's not going to happen, unfortunately. I would love this. VMware does think occasionally that they know what networking is. So a year ago, they launched vCloud Director Networking Infrastructure, which is their own Mac-in-Mac encapsulation. They couldn't use the standard one. It has to be proprietary. So it couldn't possibly interoperate with provider backbone bridges. They use their own packet format. And this is the worst part. They translate VM flooding into physical flooding. Broadcast into broadcast. Okay? So obviously this doesn't scale. It requires large-scale bridging, and that doesn't scale. And they haven't solved the broadcasting problem, so that doesn't scale. It was a nice proof of concept. It looked great. The GUI is cool. But when you want to implement that in your network, you quickly discover that this won't work. And they admitted as much because a year later, they launched another solution, VXLAN, which actually might scale. So VXLAN is bridging over IP. And a good question would be, OK, so why do you need a new standard? Don't we have GRE for that? Yes, we do. And by the way, a week after this, another draft was published, this time from HP and Dell and Microsoft and a few others. So everyone but VMware and Cisco. And that one proposed using GRE. The real difference is that with VXLAN, because it uses UDP, you get better load balancing. What they do is they take the internal MAC header they hash it into source UDP port number. And because the layer 3 switches can do load balancing on the 5 tuples, you actually get decent load balancing with this guy. By the way, this is a half-baked solution. It only defines the encapsulation. So this is how we bridge over IP. How do you do flooding? Well, you do it with multicast. What multicast group do I use? We don't want to know. It's solved through the management plane. So there is no control plane at all. It relies on dynamic MAC learning like any decent bridge. And there is no security. So still the physical infrastructure has to be secure. If anyone gets access to the physical infrastructure, they are able to send packets into any virtual segment and break into any virtual machine. That's a problem. But it's definitely better than what we had before. Some people are proposing to use this for inter-data center connectivity. Don't do it. It won't scale because it's still bridging and flooding. And it provides no traffic reduction, like OTV does, for example, from Cisco. Or what does Juniper has? BGP, MAC, MPLS-based VPNs, or something along those lines. So Juniper has a really cool standard that is MPLS VPN for layer 2. And once that gets implemented, it will be cool. But it's not shipping yet, I think. Anyway, so I gave you a number of different commercially available solutions. Okay? None of them really scales. The only thing that scales is IP over IP the way Amazon does it. It's not available as a commercial product yet. So, from the service provider perspective, you either will launch a cloud service or you will be in the pricing war with all your competitors and competing on thinner and thinner margins, which doesn't make sense. So my recommendation to every single service provider willing to listen would be, think about cloud services. And you don't have 2 years. They usually need like 2 years to launch a product. You don't have 2 years. You need to move fast. By the way, don't consider fancy technologies. You need something that will work tomorrow. Otherwise, you will be too late. So start from the business needs and don't consider whether VXLAN is better than NVGRE or the other way around. That won't work. And forget about the traditional separation of applications, virtualization people, server people, storage people, networking people. Either you get them together in the same room and they start talking to each other, or you will fail. And as I said, there is no place for blame shifting. However, this is something that will happen whether you as the organization will be there or not. It is new, it's exciting. There are a lot of unknowns, so there are a lot of problems to be solved. And you still have the opportunity to build something scalable. Because the scalable solutions are simply not available today. Okay? So this is definitely something that you should go and jump into, or at least start considering to move toward that. And there are all sorts of people doing all sorts of very creative stuff. So this is a bleeding edge technology. Like the vSider was just launched, I don't know, a few months ago. The guys were probably working for a year or 2 years on something like that. And they went public a few months ago. It was like the only product doing what they were doing. There was a guy from money.pl 2 days ago explaining how they do virtualization. And it's a pretty creative solution because they don't do virtual machines, they use Linux containers. So they were able to get some really good results because of the lower overhead. So there are all sorts of things that you could do to be creative. So go out and do it. To help you get started, there are a number of blogs that you can start reading. There are mostly, the ones I list are from the networking side. There is a great podcast from Greg Farrow and the team, the Packet Pushers. You should listen to that. And if you have any questions, now is the time to ask them. If not, you can always get in touch with me, and I always answer whatever questions you send me through an email. Yes, sir.
Question around the VXLAN. It mentioned there is no security image. But can we use VSG, for example, to kind of add the security piece to the solution?
So if you haven't heard it, the question down there, the question was, you claim that VXLAN has no security, and it doesn't. Can't we add VSG to it to add some security? Sort of. VSG will protect the VM. Okay? So VSG is like a firewall you put just in front of the VM. It will protect the VM from whatever you think the VM should be protected from. Because VXLAN is actually implemented in the same Nexus switch as the VSG offload, it will actually work well together. However, with access to physical network on which VXLAN is running, you can spoof any packet, which means that you can do things like ARP cache poisoning. So you can persuade the virtual machine, well, the hypervisors, to send you the packets that should go out into the internet, for example, or send you the packets that should be going to trusted virtual machines. And because you can spoof the layer 2 infrastructure, it doesn't matter if the virtual machine is protected, because you can spoof the session to the trusted host. And because VSG can't recognize that this is a spoofed session, it will say, OK, this is a session from the trusted host. You're in. So it's like, you have, in the physical world, you have a firewall protecting your virtual machines. But if you can connect yourself directly to the firewall doesn't help you. OK? Any more questions? Yes, sir.
OK, the question is very simple. You said that, OK, there is no time to wait. It's time to react now. And in your opinion, what's the best solution, the best approach we can use now without using the fancy cutting-edge stuff, something what works well?
You want something that works well, and you work with VLANs. Sorry. There is nothing else that would fit your requirements. Still, so if you start thinking about cloud services today, it means that in a typical service provider environment, it's at least 6 months before you will see this in production. Or more.
6 months. Very ambitious.
Or more, exactly. So you need a solution that you can deploy today. And that solution is VLANs. It has its limitations. And you have to know that with VLANs, for example, you can support a few hundred, few thousand maybe, if you are very conservative, customers. Okay? And that's how you will solve your pilot project. After that, you need to know today what is the next step. And the next step is VXLAN. I don't see any other next step, honestly. On the there is a potential that people like Nicira will come out of hiding and actually deliver something deployable. Well, probably not in 6 months. What people are working on the Zen side, because VXLAN is currently a VMware-only offering. It only works with, it will work when the beta starts, with Nexus 1000 vSwitch running inside VMware. People on the Zen side are working with Mac over GRE tunnels. And because they never thought about scalability, those are point-to-point GRE tunnels. Somehow it doesn't scale. There is Open vSwitch, which is the replacement for the traditional Linux-based vSwitch in Zen kernel. And Open vSwitch supposedly has a lot of extra features. Pretty hard to guess what they are because the documentation is not exactly brilliant. And it supports OpenFlow, which means that an OpenFlow controller plus an Open vSwitch in Zen kernel could give you exactly the same architecture as Nexus 1000V today. And if Nicira or whoever is working on that does that right, they might actually you might actually get an open source VXLAN-like implementation in Zen. So, yeah, absolutely. Okay, so they tell me we are out of time. As I said, if you have more questions, I will be around here for a while. Just find me, and I'll try to do my best to answer them. Thank you.